basically the data structure is for organizing the data in a proper manner. So for that, we are having different kinds of data structures. So that is a primitive data types, we can call it. So primitive data types in the sense that what are the data types we are using the programming language that comes under the primitive data types. So okay, that also becomes under the data structure. So okay, and one more, two more things we are having, that is the linear data structure. So under the linear data structure, we are going to learn array, so linked list, stack, queue. So these are all storing the data in a linear format. That's why we are calling them as a linear data structure. Now coming to the non-linear data structure. So here we are having different categories. So hierarchical we are having and the graph we are having. Yeah, hierarchical. So hierarchical in the sense that is the tree. So okay. So tree format, that is non-linear data structures. Yeah, it is not having any proper structure. That is, we can store the data in a tree format or in the graph format. So okay, this is all about the simple introduction for the data structures. So now I'm moving to the overview of the go for the overview of the binary search. Do you know what is that binary means?
Yes, ma'am. What do you mean by binary actually?
Binary, just binary.
I didn't actually understand your question actually.
You didn't understand my question.
Yes, ma'am. Binary is zeros and ones, is it? Binary.
So that is the binary codes, zeros and ones.
Yeah,
Now
what do you mean?
What is that binary? I'm asking, did you know what is that binary means?
No.
So how that
remember
tree, how the tree looks? Basically, it
is
is having
tree is yes, as I said, tree is a hierarchical data structure with the root and a parent and a child.
yeah.
It's hierarchical data structure, as you said.
Yes, exactly. What I mean to say, what is mean by the binary means there where the root node is having the two child nodes. Okay.
Root is having a two child.
Yeah, that's why we are calling it as a binary. Got my point?
Yes.
So, okay. So everything, whenever you are trying to learn something, you should know every term. So why we are using this? So okay, because binary search tree, binary means there we are going to have only two nodes for the root node. Okay.
Yes. Exactly.
One parent node will be having only the two child nodes. So okay.
2 child nodes.
Yeah. So that is mean by the
at most 2 children. Yeah.
Yes, exactly. So now I'm getting into this. I already discussed about this. So, okay. So a binary search tree is a data structure, hierarchical data structure. So, okay. That is the combination of the binary search and the tree. So, okay. Here, why I'm telling you the binary search means it is following that technology in the binary search tree. Do you have any idea of the binary search?
Yes, ma'am. Binary search.
Yes, right. Can you a little? Can you give me the few points? It's okay. If you don't know, it's okay. Fine. I'll
I know
help.
actually it has been a bit of like we find the middle node and compare the
Exactly. That's what you are doing here. So binary search means we are having the sorted elements in the array or the list. So okay, from that, if you want to search any element, so there you are going to get the middle element. So from that middle element, you are comparing the left side and the right side.
Right side.
So until you find your element, you will be searching for that. Searching by comparing the other elements. Got my point, right?
Yes.
So this is what the binary search tree. So I thought that you are new for the data structures, and I'm going with the pure basic part. So, okay. This is what your binary search tree. That is a binary search plus tree. So in this, so so what is tree? So what is tree? So which we are representing the data in a hierarchical format, that is completely the non-linear data structures. So here we are calling the objects the elements as a nodes. So okay, that are linked together, so forming a hierarchy. So that is what the tree is here. So actually you know this, right? What is the tree?
Yes, yes.
It is a completely tree is a hierarchical representation of the data. There you are calling the objects or the elements as a nodes. So okay, clear. So that is what the tree is. So okay. So what are the key points is so tree is made up of the nodes. So the topmost node is called the root, and the root parent node will be root node will be having the two child nodes. So those will be calling it as a siblings. So okay, a node if the node does not have any sub nodes, we can call it as a leaf. So okay, so two nodes will be having one parent node, that is must and should. So okay, these are the key points of the tree. So okay, now coming to the tree terminology. So you know, right, this is the first one is the root, and when coming to this is the parent node. So if the node is not having the any children, that will be calling it as a leaf. Okay, so and this completely will be calling it as a, so I'm combining the two nodes, so that node will be calling it as a subtree. So it is coming for the right, so right subtree, and the left part is the left subtree, we will be calling it. So okay, height is the number of edges in the longest path, so from node to the leaf. So okay, this is the terminology we are using in the tree. So this is must and should you need to know when you are coming into this non-linear data structure or the hierarchy part. So okay, and the next one we'll go for the so binary search. As you already know that, so I'll just give you the brief introduction for that. So binary search is an effective algorithm. So for finding any element in a sorted list, mainly we'll be using it for the arrays for the list. Okay. So it probably what it will do is, so we will be having the 10 elements in a sorted array. So from there, if you want to find out any element, you will be dividing that. So do you know the index numbers, right?
Yes.
So I'll just show you the example. I prepared that one also, so that's why. So okay. So this is your example. Okay. So this is the binary search, and this is the binary search tree. So this is in the linear format, and this is in the hierarchy format. Okay, and this is your example how we are finding or how we are finding this element, okay, in the binary search. So okay, I'll show you this example. This is your example. This is a visual representation. So sorry, sorry. So you know, right? So these are the index numbers, okay, and these are the elements. Now my question is how to find out the three number. So okay, how many elements we are having? It's sorry. What is the first index number?
Zero.
So first index number is here 0. So okay, and what is the last index number?
7.
So plus 7. So whole by 2. Okay. So now tell me what is the 7 by 2?
7 by 2 is 3.5.
3.5. So we are just taking the number is 3 here. Okay. So what is the index 3 we are having? So at the index number 3, we are having the 7. So what is your number? What is the number you need to find out here?
3.
So 3 is less than 7, right?
Less than 7. So yeah.
So when you are searching an element in the binary, that will be completely in the either in the ascending order or in the descending order, right?
Yes.
So yes, so 7, so 3 is less than 7, then you are moving to the left side. If the number given, if the given number is greater than the 7, you can move to the right side. So okay. So now you got the value is 3. Yes, right? So you need to leave this 3, index number 3. So what is the first index number here? So that is the 0. Okay. What is the last index number here?
7.
2. No, 2.
Sorry,
So because you need to leave that 3 index number. Okay. So 2. So 2 by 2, what you got?
2. 2 by 2, 1. 1. 1.
1. So at index number 1, what is the element you are having?
3.
3. So that's how you are finding the
The
element in the binary search. Now you got my point, right? This is very simple. You need to sort the numbers first. You need to sort the elements either in the ascending or in the descending order.
order.
Okay. So, okay, if you don't sort the elements in a given array or anything, any data structure, you are not supposed to find out the elements. So, okay, that is not possible to find out any element. Clear?
Yes, miss.
And one more thing you need to understand, that is, so here you are getting the 3.5. 7 by 2 is 3.5. So you need to ignore the point number. That is a decimal number. So, okay, you
Yes,
got it right?
yes.
So, okay, this is all about the binary search. So the same way in the binary search tree, what we are doing is, so we are forming a tree. So, okay, that will be looking at, so I already shown you. So, okay, this is your binary search tree. So, binary search tree, what is the main rules in the binary search tree is, so, okay, what is the value here in the root node? What is the value you are having?
25.
25. Yes, right? So when you are inserting the elements or when you are forming the binary search tree, so at the left side, that will be less than the given number. So, okay. So you are having the 25 or the root node. Yes, right?
Yes.
So at the left side, so mainly this is the rule. So at the left side, the number should be less than the root node.
Root node.
Clear?
Yes.
So and at the right side, what is the number you are having here?
At the right side, we are having a number of 35.
Yes. So the at the right side, the number should be greater than the
node.
given number. So this is how we are going to form the binary search tree. Got my point?
Yes, ma'am.
So okay. So that's how we are doing it. So don't follow this. Okay. That is an error. Okay. So these are the main. So also in the left side, that should be smaller than the nodes value.
To the right side should be greater than
Right side, that should be greater than the nodes value. So, okay, this structure helps to quickly find, add or remove values. So, how the binary search is involving in the binary search tree, I'll explain. So, actually, this is how we are having, right? So, this is the tree we are having. So, I'll give you one number to find out. So, okay, I'm giving you the number that is the 40. So, okay, which is present in the binary search tree. So first of all, okay, fine. I'll stop it here and I'll explain you how we are going to insert the elements into the binary search tree. So, okay, how we will form the binary search tree, I'll explain with an example. Then after we'll go for the how we are finding, how we are searching the element in the binary search tree. Okay, you got my point?
Yes, ma'am. Got it.
So this is your example. So, okay. So this is your example. So I'm having the elements of 45. So, okay, 15. I'll show you the final graph here. So this is your graph. 45, 15, 79, 20, 10, 20, 55, 90, 12, 50. If you have a note on pen, please note down the numbers. I'll explain you.
Okay. Yes, ma'am. Repeat the numbers.
If you have any paper or any note.
Yes, ma'am. I have the papers. Tell me the numbers.
So 45,
45.
15,
Okay.
79.
45, 15, 25.
Or else try to write it in
Yes,
a
ma'am.
random way.
Okay.
Try to write the elements in a random movement. Okay.
Okay.
Now tell me in which order you wrote the numbers.
Simple, actually. If we make the 45, if we take the 45 as the root node, we insert 15 and 17 to the left.
No, no, no. I'm just asking you, write down just in a linear format, write down the numbers.
Linear form. Okay.
అంటే ఒక స్ట్రైట్ గా నంబర్స్ ఇక్కడ ప్రెసెంట్ అవుతున్నవి స్ట్రైట్ గా రాసేయమని చెప్పి అడుగుతున్నాం. సో ర్యాండమ్ గా రాసినా పర్లేదు. ఐ విల్ ఎక్స్ప్లెయిన్ హౌ వి ఆర్ గోయింగ్ టు ఇన్సర్ట్ దమ్. Write the numbers, but this is the final structure you are going to get.
Yes.
So okay. So now moving to the explanation. So okay. Wait a second. So our first number is 45. So that's why we are making that into the root node. So okay. And the next number we are having is 15. So okay. So 15 is less than 45, right? So
Yes.
whenever an element, given element is less than the root node, what we need to do?
Insert it to the left.
So we just need to adjust in the left side. So okay. And the next number is 79. So if the number is greater than the given root node, so what we need to do here?
We insert it to the
So,
right.
so we need to insert into the right side. So now coming to this, next element we are having is 90. So okay. Now from the starting root node, you need to compare it. So okay, but you should not replace the root node. Got my point? Once you place the elements in the tree, you are not supposed to change anything. Just you need to follow it. So now we are comparing 90 greater than or less than 45. So you need to check it. So is 45 is greater than 90?
It is. No, it is not. It is not. So
45 is not greater than 90.
90 is
So
greater than
that's
45.
yes, 90 is greater than 45. That's why we are moving to the right side. Clear?
Yes.
So okay. And then after now you are having the 79 here. Okay. Now you need to compare this 90 with the 79. So 90 is greater than 79. Yes, right?
Yes. Yes.
So obviously you need to place it at the right side. So okay. So
At the
this
right
is
side.
how you need to place it. Got my point?
Got it.
So now my next element is 10. So okay.
Mhm.
Now I need to compare the 10 with the 45. So 10 is less than 45, right?
That is
If
option
the
C.
so if the number is less than the given root node, then you need to move to the left side.
Left side.
So now already I'm having the another node here. So I need to check that 10 again with the 15. So okay, I need to check the 10. So 10 is less than 15. Yes.
Yes.
So that's why we are placing the 10 for the as a child node for the 15 at the left side.
At the left
Got
side.
it? Got
Yes.
it?
Yes.
So now I'm having the element is 55. So okay. So 45 is greater than 55. 45 is greater than 55.
Huh.
Huh?
45 is not greater than 55. 45 is not
So,
greater.
so that's how you need to involve in this. I'm asking you the question 45 is greater than 55.
No,
The
no,
first
it is
answer
not.
should I get? The first answer should I get is not. So what you are telling is
I figured it is ulta. 55, 45 is greater or not actually. Yeah.
So 55 is greater than 45. My question I repeated so many times is 45 is greater than 55.
Yes.
No, right?
No, it is not. It is not greater than 55. Yeah, I'm sorry.
So that's how we analyze how presence you are in the class. So, okay.
Yes.
So 55 is the greater than 45. So
Right.
that's why we are moving to the right side.
Right
So,
side.
okay. Then after 55 is less than 79. Obviously, we'll place that at the left side for the 79.
Left side of 79. Yes.
79. Now got my point?
Got it.
So now what is the number you are having? Now you need to tell it.
Okay.
So what's the number you are having?
So we are having 45.
Look at the screen. I'm highlighting that number. Seventh one.
I can see your screen actually. That's it.
Sorry, you are not getting my screen?
No, ma'am, I'm not getting your screen from the past 20.
You need to inform it, right? before
No,
itself.
I was just noting it down and actually.
No, I am sharing my screen
No,
actually.
I can only see PowerPoint here and the binary search tree. The slide only I'm seeing actually. The entire screen I'm not.
So you're not getting this Word document.
No, ma'am, I'm not getting the Word document.
Oh, I'm sorry. I thought you are
No, it's fine. It's fine.
that it displaying. Okay, fine. So the next number is 12. So my next number is 12. Okay. So now tell me how we are going to insert it.
We insert it to the left of 15 actually.
Left of
15.
exactly. Huh? Not the left of 15.
12, right?
Yeah, my number
Right,
is
right,
12.
right.
Come from the top. Come from the top. Don't jump for the direct answer. It's okay. Is 12 is greater than 45?
No,
No, right? Then at which side it should go? ఏ సైడ్కి వెళ్ళాలి 45 లెస్ దాన్ అంటే 45 కంటే లెస్ దాన్ ఉంటే నెంబరు
left.
లెఫ్ట్ కదా మనకి నెక్స్ట్ నెంబర్ ఏది ప్లేస్ చేసాం 45 కింద లెఫ్ట్ సైడ్ లో
Less
యాజ్ ఎ
than
రూట్ నో
15.
15. సో నౌ కంపేర్ 15 విత్ ద 12.
No, 12 is less than 15. So left
12 is less 12 is less than 15. Yes, right? But we already placed the 10 at the left side, right? For the 15.
So right side of 10, it will be go to writing. Right
Yes, exactly. We need to place the 12 at the right side of the 10.
side 10.
Now got my point?
Yes, ma'am.
So now listen to this carefully. So now you got the 12. Okay. So can we change the 10 number instead of the 12?
I didn't get your question.
So basically, 12 is greater than 10, right?
Yes,
And 15, 12 is less than 15, right?
perfect. Yes, ma'am.
Is it possible to replace the 12 number at the 10 note?
Still
10
continue.
మనము 15 కి లెఫ్ట్ లో 10 పెట్టాం కదా
Hmm.
నా క్వశ్చన్ ఏంటిదంటే ఇప్పుడు 12 అనేది 10 కంటే గ్రేటర్ గా ఉంది
Hmm.
అవునా 12 15 కంటే లెస్
Hmm.
సో ఇప్పుడు 15 10 కంటే గ్రేటర్ కాబట్టి నేనేం అడుగుతున్నానంటే 10 ప్లేస్ లో మనం 12 ని రీప్లేస్ చేయొచ్చా
Yeah. 10 plus 2. Okay.
ఈజ్ ఇట్ పాసిబుల్ టు రీప్లేస్ ద 10?
Yes, it is. We can replace it, isn't it?
నో
How?
I already in the beginning of the binary search tree only I'll explain.
I am forgetting something.
I already told you you are not supposed to change whatever the elements you are inserted.
Hmm.
Once you place
We can
చేసిన
delete it
తర్వాత
and replace it actually. That's
you can delete it, but you are not doing the delete operation here.
Without deletion, it is not possible. I figured.
Yeah, without deletion, I'm asking you. Without deletion, is
Without deletion, it is not.
whenever at the insertion operation itself, is it possible to change the element?
No, it is
No,
not
no.
possible.
So that's my question. That's my question.
We
Okay.
have to search for that element, delete that element, and we can insert a new element.
Yeah, whenever you delete that, so or you can replace it. So okay, delete చేసిన తర్వాత మనము రీప్లేస్ చేసేకి అవుతుంది ఇన్సర్షన్ చేసేటప్పుడే మనము రీప్లేస్ చేసేకి అనేది అవ్వదు
Hmm.
ఓకే సో ఓకే the next one you are having the 20.
Hmm.
So okay, so now and the next one you are having is 20.
Hmm.
So okay, so now you need to compare from the starting. So 20 is less than 45. Obviously, it will go for the left side. And again, you need to check it for the 15. So, okay. So 20 is greater than 15 or not?
It is.
Yes. So
So it
that's
will
why
go.
you need to place at the 20. So మనకి ఇక్కడ ప్లేస్ చేయలేదు ఇంకా 15 కి రైట్ సైడ్ లో మనం ఏ ఎలిమెంట్ ప్లేస్ చేయలేదు కాబట్టి దట్ విల్ బి గో ఫర్ ది right side of the 15. So,
Right
okay,
side
and the
of
last one we are having is 50.
50.
So 50 is greater than 45.
45.
Yes.
So it will
So
go
it
right.
will go for the right side. So 50 is less than 79.
Yes.
Yes. So then obviously it will go for the left side.
Left
And
side.
50 is less than 55.
Right. So it will again go left.
Again go left. So okay, this is how the binary search tree we are inserting the elements.
Inserting
Now
the-
got my point, right?
Yes, ma'am. Got your point.
So this is all how we are forming the binary search tree.
Mhm.
So
Yes.
okay. So if I ask you the question,
Ah,
how we are finding the element? So I ask you to search for the element 20. So okay. Now can you explain me? You know the binary search, right?
yes, ma'am.
So now uh, just give a
Hmm.
uh, so what is that? Give a try to find out the element 20.
Okay.
Hmm.
Mm, if it is 20, we just traverse it. If the key
So
element or the search element is less than the root data, we go in the left subtree. If it is greater than the root data, we go into the right subtree.
yes,
So
you are in a right path. So in the traversal, we are having the three types. So okay, that will go into the
pre-order, in order, and post-order traverse.
yes, exactly. Pre-order, in order, post-order.
And
So
post-order.
okay.
Hmm.
So I asked you for the 20, right? You need to check it with the root node. So
Root
20 is greater than 45.
20 is less
No.
than
So that
45,
is
so
less
left
than
side of
45. That you will move to the left
but
side.
but greater than 15, so
So it will move to the
right side.
right side. So okay, now you got this 20 value at the right position of the 15. So
Hmm.
okay.
Yes, ma'am.
So this is all about the binary search tree. We are not going into the any operations. I'm just ending up this session here itself. Okay. This is
Uh-huh.
all about the
Hmm.
binary search tree for
Ah,
the demo. Okay. Do
hmm.
you have any doubts regarding this?
No,
Or
no,
you want to know anything?
no doubts as of now, ma'am, actually.
So okay, fine.
Hmm.
Thank you so much.
Thank you so much for it,
Okay.
ma'am.
Thank you so much. And this is the binary search tree. If if we have the further classes, we'll go for the operations. So, okay.
Yes, ma'am. Yes, ma'am.
Thank